Okay, so lesson 9.1, mathematical patterns. So this is just kind of a general introduction, looking at some patterns, identifying some patterns, being able to write rules, okay, specific types of rules. So a sequence is an ordered list of numbers. Each number in a sequence is a term of a sequence, and you can represent a term of a sequence by using a variable with a subscript letter. So when you have a sequence of numbers, it doesn't necessarily have to have a certain pattern. It may or may not, but a sequence of numbers, ordered list of numbers. Each number is a term, meaning if we have the sequence of numbers 1, 4, 9, 16, 25, ... n squared. So A1 represents that this is the first term. A2 represents this as the second term, third term, fourth term, fifth term, and then right here, A sub n, this would represent the nth term. In other words, a sequence of numbers can go on and on forever, right? So this would be the nth term, and then this would represent your pattern or whatever the rule is. Now, specifically, we're going to start off talking about an explicit formula. An explicit formula describes the nth term of a sequence using the number n. So, for instance, using the above sequence, the nth term, well, what are we always doing here? Can you guys see that pattern? Okay, so I've heard adding odds. Do you guys see the adding odds? Plus 3, plus 5, plus 7, plus 11. Okay? Or, what do you guys mean squares? Okay. The first term is 1 squared. The second term is 2 squared. The third term is 3 squared. The fourth term is 4 squared. The fifth term is 5 squared. Based on what we're seeing, are they both accurate? Yeah, unless we go on and somehow they don't continue, they both work in this case, don't they? Now, if we are writing the sequence using just n, where it's based on the nth term, we're going to want to use the n squared pattern. Because if I say, okay, can you tell me the 10th term? Well, if I'm asking for the 10th term, n is 10. So what's the 10th term then? 100, because it's doing 10 squared, right? Okay. Now, if it's the one where it was adding odds, what are you always going to have to know to be able to do the pattern adding up the odds? If I ask you for the 10th term there, what are you going to have to know? The term before it, right? In order to find the 10th term, you'd have to know the 9th term if we're just adding odds. In order to find the 9th term, you have to know the 8th term. And so you have to know all the terms working up to it, right? So we're going to be talking about two different types of formulas. We'll talk about both of those. But in talking about this one, this is what's called the explicit formula. Okay? Where, your formula is described using n, and n represents the nth term. So, for instance, the 9th term is 9 squared, which could also be written, of course, as 81. And I didn't write it up here, but you guys saw that this is 1 squared, 2 squared, 2 squared, 3 squared, 4 squared, and 5 squared. Yes? Maybe that's not the first thing you saw, but I'm hoping you eventually saw it. Okay, so let's look at example 1 here. Talking about generating a sequence using an explicit formula. A sequence has an explicit formula, so they're giving you the explicit formula. A of n equals 3n minus 2. What are the first 10 terms of this sequence? So if I want to find the first term is denoted as A of 1. How am I going to find the first term? put 1 in for n, right? That's how an explicit formula works. So we're going to be doing 3 times 1 minus 2. Do the math. 3 times 1 minus 2 is 1. How do you find the second term? Plug in 2. 3 times 2 minus 2. 3 times 2 minus 2 is 4. What about the third term? Plug in 3. 3 times 3 minus 2? 7. The fourth term. 3 times 4 minus 2? 10. Okay, keep going. The fifth term. 13. 3 times 5 minus 2? Sixth term. 3 times 6 minus 2? 16. The seventh term. 19. The eighth term. 3 times 8 minus 2, 22. The ninth term. 3 times 9 minus 2, 25. And the 10th term. 3 times 10 minus 2, 28. So you can list all 10 terms, yes? 1, 4, 7, 10, 13, 16, 19, 22, 25, 28. What do you notice about the pattern as you look at this sequence of numbers? It's adding 3 each time. Where is that 3 in the formula? As in, what am I trying to connect here? That 3? Is that what's being multiplied by whatever number problem you're on? Or whatever term number you're on? Okay, so that 3 right there, whatever's being multiplied there, what's kind of in the slope position, if you will, talks about how many we're adding each time. We're adding the 3 each time. Okay? The minus 2 helps us decide where to start here. And the fact that it was the 3 minus 2 tells us to start at 1. Okay, questions there? Okay. B. A sequence has an explicit formula, A of n equals 12n plus 3. What is term A12 in this sequence?
For A12 equals 147.
Okay, so how do we find A of 12? You're putting 12 in for n, because it's the 12th term. 12 times 12 plus 3, which is, I agree, 147. Now, that formula was helpful there, wasn't it? Because in this case, because it was an explicit formula, we didn't have to go back and find the first 11 terms to get that. Okay? So, different types of formulas have different advantages, disadvantages, depending on what you're being asked to do. If you're asked to find a certain term number, an explicit formula is going to be your best. Okay? And so that's what we have right here. That was an example of explicit. You know, in this case, yeah, we worked with finding all of them. In this one, I just said, okay, find the 12th term. We could find the millionth term here, and it would be just as easy. Okay. Next part. Sometimes you can see the pattern in a sequence by comparing each term to the one that came before it. Okay, so now instead of talking about explicits, we're going to talk about a recursive definition. So the example you'll notice here, 133, 130, 127, 124. What's the pattern you see here? Yeah. Most of us would probably say subtracting 3. Okay, decreasing by 3, adding negative 3, however you want to express that. Okay, so we're going to talk about a recursive definition. And a recursive definition is written based on the previous number, based on the previous term. So recursive definition, for a recursive definition to work, there's 2 parts. There's an initial condition. Okay, the initial condition just tells you what's your starting term. What is term number 1? And so, in order to give an initial condition, A of 1 equals. So what is the first term? So when you're given a recursive definition, you have to have that first term. Because if you're always going to have to go back to the previous term, we have to have a starting place, don't we? And if we don't have that starting place, we can't do anything with this. Now, a recursive formula, it's a formula for A of n based on the previous term. And so the previous term is always going to be referred to of A of n minus 1. Okay, so if we're talking about the nth term, what term comes before n? Well, take off 1 and it's n minus 1, right? So, Well, and it's, okay, so let me ask this. What term comes before the 15th term? 14th term. How did you get that? You subtract 1. So if I say what term comes before the nth term, the nth, the nth term is the n minus 1 term. I could also turn around and say what term comes after the nth term? N plus 1. Okay? So you can always add them over, keep adding there. Okay, so in this case, based on the problem we were talking about, the first term was 133. The rule here is in order to find the nth term, you take the n minus 1 term and subtract 3. So think about it. If I want to find the 4th term, what's that mean I'm going to have to do? Take the 3rd term and subtract 3. And that's what those are talking about. That's what a recursive definition works with. Okay? Now, as I look at my notes, I decided last time I taught these notes that I didn't like these examples. So I'm basically going to give you different examples for ABC. So hopefully you haven't started ABC because as I'm looking at my notes, I have them all scratched out. I'm going to give you new ones. Can you handle that? Okay. So, notice the directions in this section. We are writing a recursive definition. So, this one is, based on knowing the previous term. Okay, so 3, 6, 12, 24, so on and so forth. Observations, thoughts? Multiply by 2? So in order to go from 3 to 6, you Multiply by 2 and it continues. Now you're to go from 6 to 12, you multiply by 2. 12 to 24, you multiply by 2. If I ask you to find the 100th term, what are you going to have to do? Multiply by 2 a whole bunch of times? Okay. I'm not asking you to find the 100th term, but I'm just saying if I did. Now, for a recursive definition, remember there were 2 parts. The first part is you have to tell me the initial condition. In order to get full credit on a recursive definition, you have to be able to tell me the initial condition. A of 1. What is A of 1? 3. A of 1 represents your first term. What's your first term? 3. What? It does. Sorry, thank you. Okay, so A of 1 is 3. That is one of your 2 pieces required. Then, in order to write the actual part of the recursive formula, it's always going to be A of n equals, and it's always going to be using the previous term. So how do you find the nth term? We're going to have to what? Okay. In order to find the nth term, like for instance, in order to find the 5th term, what am I going to have to do to find the 5th term? Multiply what by 2? The previous term, right? So, in order to find the A of nth term, I'm going to have to do 2 times, how do I show the previous term? A of n minus 1. And again, this is a recursive formula. And remember, that A of n minus 1 represents the previous term.
So it was going to be minus 1?
On the A of n? Minus, yes. Yeah. In a recursive definition, it will always be A of n equals, and after the equal sign, it will include an A of n minus 1. Yes, always. Yes. Can I trust you with my whiteout?
Don't break it.
Huh? Well, I'll be honest. I haven't used this in
A long time.
forever.
She barely makes mistakes. You don't.
No, I use the tape.
Oh.
Not that I barely make mistakes. Trust me. I use the tape. I love the tape because I don't have to wait for it to dry.
Do you ever use black unless you're changing the color? No, I've just never seen you use black ink.
There's no fun in black ink. In all honesty, I don't use the black because I want it to stand out from the rest. Like what's already printed there. Did it work?
Yep. Thank you.
Okay.
So just,
Yes.
how do you know why all the Spanish kids are walking down the hall with white symbols in their hand?
Pinata day. That's my guess.
They're so happy.
Okay. We have lost focus.
They're all.
Okay. I would say, can we talk about B now, but you guys don't even know what B is, do you?
Nope.
80. 77. 74. 71. 68. Now, one recommendation I always have. Once you come up with what you think is happening, my suggestion, always check it all the way through. Usually once you see something, you're good to go. But always check it all the way through. Does it work through all the terms that are shown? Because if it doesn't, we might have a problem, yes? Okay. So, observations about this sequence.
You're going out for work.
80 minus 3 is 77. 77 minus 3 is 74. 74 minus 3 is 71. And 71 minus 3 is 68. Okay. What do I have to do for a recursive definition?
A1.
Okay. Initial condition. What is A of 1? A of 1 is the first given term, which is 80. And in a traditional problem like this, guys, A of 1 will always be given. You just have to identify it. You just have to write it down and tell me that you know what it is.
So, like, on this one, it's a little different than the last one. Can A of 1 be first before, like, the other term? Does that make sense? Like, could we do, like, since this one's, like, subtracting, could we put, like, A of 1 minus something in the bottom? A of N, sorry, A of N, not A of 1. A of N minus 1. Can we put that in front of?
No, when you give a recursive formula, you're going to want to start with A of N.
Okay.
I mean, I guess you could mix it around if you really wanted, when working with it.
No,
But
I'm saying, like, the 2. So, like, let's go to the last one, like A. So the 2's in front of A of
oh, I see what you're saying.
Can we have that A of N behind? Can we have a term behind that?
Yes, yes. I think I'm with you now.
Yeah, I did not.
Okay, just go with it. Okay, guys, focus up here. Go with it. I think I'm on the same track as him
I
now.
understood.
Okay, so recursive step. We've got our initial condition. The sequence starts at 80. Now I need the formula. How do you always find the next term? We take A of N minus 1, which represents the previous term, and we subtract 3. So how am I going to write that? A of N minus 1 minus 3. Yes, you can put that minus 3 out there. Now notice, I tried to make a point of it in that, can you tell my N minus 1 is subscript? It's little, right? My minus 3 is full size. Can you tell that? That is the one thing I need you guys to be careful of, because so often when I grade tests, like exponents, sometimes you guys get guilty of making your exponents as big as the rest of your problem. Okay, you have to be careful. Subscript, same thing. Don't make it as big as the rest of the problem. Okay. Got one more for us today. 4, negative 8, 16, negative 32, 64. Okay. Thoughts?
Multiply by -2.
Okay. If we take off the negatives, do you see 4, 8, 16, 32, 64? It's always doubling?
Yeah.
It's always multiplying by 2. Anytime you can recognize that and the signs are alternating, plus, minus, or minus, plus, it does just mean you're multiplying by a negative. So yes, check it out. 4 times negative 2 is negative 8. Negative 8 times negative 2, positive 16. 16 times negative 2, negative 32. Negative 2 times negative 32, positive 64. Sounds good to me. Okay. What do you have for this recursive definition? Dayton stole the easy part. I say not that the hard part is horribly difficult, we've already identified. A1 equals 4, because the first term is 4. How do we write the actual rule then? What are we writing, Carter?
A of N equals -2 times A of
Okay. A of N equals -2 times a of n minus 1. On the conversation from the last problem about putting things in front of, behind a of n minus 1, on a multiplication something or other, I would put the multiplying number out front. That's just logically how we do it. You know, it's rare that you guys don't usually write x times 2. You usually write 2x. Those type of things. Okay. I think that's a good stopping point, isn't it? So, we will come back on Monday and talk about how to write explicit formula on the back of this paper. Okay? I would like to think you should have some work time on Monday. I'm changing several of those formulas too on that page. So, but available. I believe I'll probably have it due on, Tuesday then? However, you should have some work time on Monday, I would think.